Hello students, I hope you all are fine. As you know that yesterday we were discussing about chemical properties of the alkanes. Three properties we already discussed. So two or three more remaining. So today we will discuss about them. And one more topic we will discuss, that is the conformations. Okay. First we will discuss remaining properties. Reaction with steam. Reaction with steam. Students, when methane CH4, when methane react with steam formula same, water, means around at 1273 Kelvin if we will heat. In presence of nickel, then it decomposes and it gives us carbon monoxide plus hydrogen gas. Plus hydrogen gas. If alkanes react with steam, that they produce hydrogen gas. And student, this method is more common method for production of the hydrogen. We use this method for production of hydrogen gas also. You all know very well about hydrogen gas. Hydrogen gas is colorless, it is odorless, okay, but it burns and it produces pop sound. It produces pop sound. For production of the hydrogen gas, we can use this method. We can react methane with the steams at very high temperature. And student, combinedly CO plus H2, combinedly, this one is the formula of water gas. If it is asked what is water gas, CO plus H2, it is the water gas, and CO plus N2, producer gas. This is the producer gas. Okay. One more method of preparation is pyrolysis. Pyrolysis. Pyro mean heat. Pyro mean heat. Lysis mean breakage, decomposition. Pyrolysis means decomposition. In presence of heat. In presence of heat. Here we are discussing about alkanes. So pyrolysis of alkane means when higher alkanes can decompose into smaller, can decompose into the smaller alkanes when pyrolysis means in presence of heat. In presence of heat, higher alkanes can be decomposed into smaller alkanes in presence of heat, and this is known as the pyrolysis. For example, if we have, it can give us alkane as well as smaller alkenes also. As well as smaller alkenes also, it can break. Like, if you have hexane, this is alkane, CnH2n plus 2. Hexane means 6 carbons. So C6H14. If you are having hexane, and if you heat this one at high temperature around 773 Kelvin, okay, then it decomposes into smallers. Like Below that we can take butane. Butane is C4, C4H10 plus two more carbons are there. So in ethane also, in ethane also, clear? It can decompose. Then 4 to yes C4 H10 C2 yes. Then it can break into hexene, in hydrogen gas, means in fragments it can decompose. Clear or not? Yes. It can decompose into propane. There are three carbons in propane plus ethane 3 to 5 plus methane 3 to 5 and 1 6. Clear? Means higher alkane can be decomposed into smaller alkanes or alkenes. Smaller alkanes or alkenes. Okay. Here we should take 4 and 2 6. So C2H4 only. Means in alkene it will. Because we are having only 14 hydrogens na. 14 hydrogens. Means you will see number of hydrogens and carbons would be same. Only higher alkanes can be decomposed into the smaller alkanes or alkenes. Clear? After heating at high temperature. And this is known as the pyrolysis. Any doubt in this one? Yes. So here we have completed our chemical properties. Here we have completed our chemical properties. Now we will discuss about one more topic, that is conformation. It is important topic, conformation. Students, what do you mean by the conformation? Here alkane we are discussing, so conformation of the alkane. Conformation of alkane. In alkane you know very well, there is single bond between carbon and carbon. Carbon and carbon? Single bond. Okay. Student, this carbon to carbon single bond means it is free to rotate. It is free to rotate. Let us consider we fix this carbon. Okay. And we can rotate this one. We can rotate this one with respect to this. If we will rotate, then different spatial arrangement we will get. This process is known as the conformation. And the arrangements which we get after rotation are known as the conformers. Like if you have one carbon this one and one this one, other valencies we will complete with hydrogens. What will happen, students? This carbon is fixed. इसको हमने फिक्स किया. ओके क्योंकि सिंगल बॉन्ड है, सो जो कार्बन है इट इज फ्री टू मूव. दिस मॉलिक्यूल इज फ्री टू मूव. क्लियर? इसको हमने एक को फिक्स है, दूसरे मान लो ये हमारे पास एक कार्बन है, ये कार्बन है, ये जो दूसरी जो कार्बन है ये हमने रोटेट की है, तो इसको रोटेट किया है, सिंगल बॉन्ड है, इजीली रोटेट हो जाएगा. ओके. अब जब रोटेट होगा तो जो ये हाइड्रोजन्स हैं, जो 3 हाइड्रोजन्स हैं, तो इनकी पोजीशन क्या होगी? चेंज होगी. इनकी जो पोजीशन चेंज होगी तो हमें डिफरेंट अरेंजमेंट्स मिलेंगे, एंड दोज अरेंजमेंट्स आर नोन एज द कन्फॉर्मर्स. Clear? And this phenomena is known as the conformations. Clear or not? But students, ये ठीक है कि भाई रोटेट करते हैं, बट कंप्लीटली फ्री नहीं होते रोटेट करने में, क्योंकि कहीं ना कहीं चलो ये बॉन्ड तो हमारा सिंगल है, बट जो कार्बन्स के साथ जो हाइड्रोजन्स जो अटैच हैं तो वो एक दूसरे को क्या करेंगे, हिंडर्ड करेंगे, एक दूसरे को हिंडर्ड करेंगे। ओके, तो कुछ ना कुछ उनके बीच में रिपल्सन होगा इन हाइड्रोजन्स की वजह से, क्योंकि ये अभी देखो हमने 3 डायमेंशनल को 2 डायमेंशनल पर यहाँ पर शो किया है, बट जब ये 3 डायमेंशनल है तो यहाँ क्या होगा, कुछ ना कुछ रिपल्सन होगा इनके बीच में, तो जिसकी वजह से यहाँ एक स्ट्रेन जनरेट होगा, देयर विल बी जनरेट अ स्ट्रेन, एंड दैट इज नोन एज द टॉर्जनल स्ट्रेन, दैट इज नोन एज द टॉर्जनल स्ट्रेन। There will be an energy barrier, there will be an energy barrier, okay, which resists to rotate the bond, means this rotation is not completely free due to presence of these hydrogens here. Okay, so this is known as the torsional strain here. Clear or not? Now we will write the conformers of ethane, conformers of the ethane. We can write in two ways. One is the Newman projection. Newman projection. In Newman projection, what will you do? In Newman projection, what will you do? You are having ethane, means CH3 and CH3. One carbon is fixed carbon. One carbon is fixed carbon. The fixed carbon you will show with a point only. You will show with a point only. And the carbon which is going to rotate, you will show with a circle. You will show with a circle. Okay. And you will show hydrogens by the lines, by the lines. You know, in ethane mainly there are the two conformers. One is the staggered and second one is the eclipsed. One is the staggered and second one is the eclipsed. Staggered is that in which both carbon in Newman projection, the one carbon which is fixed carbon, we will show with a point only. We will show with a point only. Okay, and these are the hydrogens. These are the hydrogens of fixed carbon. Okay, this is ethane, CH3. Let us consider this one is fixed carbon and it is going to rotate. It is going to rotate. So this carbon we will show with a point, and these are the 3 hydrogen of this one. These hydrogen we will put with angle 120 degree. Clear or not? Then the carbon which is going to rotate, we will show with a circle. The carbon which is going to rotate, we will show with a circle. Okay, and hydrogens of this carbon, because they are going to rotate. So firstly, let us consider these are the hydrogens, mean just nearly near to the hydrogens of the fixed carbon. एक रोटेशन में ऐसा है कि जो हमारी फिक्स्ड कार्बन के हाइड्रोजन्स थे और जो हमारी रोटेटेड कार्बन के हाइड्रोजन्स थे, ये दोनों एक दूसरे के पास पास आ जाएंगे। तो पास होंगे तो क्राउडनेस ज्यादा होगी, तो हिंड्रेंस ज्यादा होगी, रिपल्सन ज्यादा होगा और टॉर्जनल स्ट्रेन भी क्या होगा, ज्यादा रहेगा। टॉर्जनल स्ट्रेन भी क्या होगा, वहां पर ज्यादा होगा। क्लियर है? तो दैट इज नोन एज द इक्लिप्स्ड फॉर्म। That is known as the eclipsed. One conformer is eclipsed. Clear or not? If we rotate this at 60 degree. If we rotate this, means एक हमने क्या लेना है, in which this is the fixed carbon, so hydrogen will be also fixed. Hydrogen will also fixed. Clear? Second one, which is the carbon which is going to rotate, that is थोड़ा थोड़ा हमने रोटेट किया, ये हाइड्रोजन यहाँ से यहाँ आया, ये वाला यहाँ से यहाँ, यहाँ से यहाँ. एक जो हमारी जो मीन्स मोस्ट कॉमन स्टेज है कि इसमें जितना मैक्सिमम हाइड्रोजन्स जो थे हमारे, वो जितना मैक्सिमम फार अपार्ट जा सकते थे वो पहले से ही हमने उनको रख दिया. क्लियर? कि भी मैक्सिमम इस कार्बन के हाइड्रोजन्स में एंड इस कार्बन के हाइड्रोजन्स में जितनी मैक्सिमम रिपल्सन हो सकती है उतनी मैक्सिमम रिपल्सन यहाँ है. क्लियर? क्योंकि अगर यहाँ आएगा तो ये इसके पास आ जाएगा. अब इनमें और इसमें जो मैक्सिमम रिपल्सन ऑलरेडी है, दैट इज नोन एज द स्टैगर्ड फॉर्म. That is known as the staggered form. Clear or not? Some structures we can form in between them. Some structures we can form in between them, like this. This hydrogen, this hydrogen, this hydrogen. Here, this hydrogen after rotation may be only here, maybe here only, this may be here only, this here only. Means some structures also lies between them. Those are known as the skew. Those are known as the skew structures. The structure between them are known as the skew structures. Okay, but basically we will discuss only these two. One is the eclipsed, second one is the staggered. Okay, here because hydrogens of both carbons are nearly means they are nearby to each other. They are nearby, so further repulsion possibility is maximum here. That's why it is least stable. It is least stable. And here torsional strain will be also maximum. Torsional strain will be maximum. Clear? But यहाँ जो हमारे हाइड्रोजन्स हैं, they are already maximum repelled. Maximum repulsion already taking place here. So possibility of further repulsion is minimum. क्लियर और नॉट? सो फर्दर रिपल्सन की यहाँ पर पॉसिबिलिटीज नहीं है, क्योंकि हमने पहले से ही दोनों के हाइड्रोजन को इतनी डिस्टेंस पे रखा है जितना वो मैक्सिमम जा सकती थी. ओके, सो इट इज द मोर स्टेबल. इट इज द मोस्ट स्टेबल and it has minimum torsional strain. It has minimum torsional strain. Clear? And students, angle between them, this one is known as dihedral angle, or we can say torsional angle or dihedral angle. Clear or not? So these are the conformers, basically eclipsed and staggered. Here eclipsed is less stable and staggered is small. Why it is? Because जो हमारी staggered है इसमें already maximum repulsion है, further repulsion possibility बहुत कम है. That's why it is more stable. Okay? और क्योंकि ये दूर दूर हैं तो repulsion अब इनमें कम है, तो torsional strain भी क्या होगा यहाँ पर? कम होगा. But students, they are interconvertible. They are interconvertible. Means if I rotate further at 120 degree, this one, okay, then what will happen? Further it can convert into this one. Clear or not? Means This energy level between them is around 12.5 kilojoule per mole. This is the energy barrier. This is the energy barrier between them. Clear or not? So this energy barrier can be overcome. Okay? Yes. And these are the interconvertible also. Further by rotation they can interconvert. Clear or not? This is known as the Newman projection. One more projection is there for showing this, that is the Sawhorse projection. Conformers we can show in this way also. The bond between carbon and carbon we will show in this way. Upper part should be in right side and lower in left side, in this way. Both carbon we can show. Then this carbon is the fixed carbon. This is the fixed carbon. Hydrogens are these. Okay. And it is rotated carbon. If, because they are nearby to each other in case of the eclipsed. In case of the eclipsed. So maximum at the same position they are. Okay, means they are nearby to each other. So one carbon, this is the fixed carbon. We will put at the lower end. Lower end जो हमारा है ये हमारा in क्या होगा in left side and it will be in right side. Okay. Then this is the eclipsed. But students, same. It is fixed, so hydrogens will be fixed. And all are at 120 degree. All are at 120 degree. Then in staggered form, hydrogen will be far apart. Then you can show hydrogen in this way, just opposite. Clear or not? So there are two types of the projections. One is the Newman projection. In Newman projection, you will show the conformers in this way. You will show the conformers in this way. And in Sawhorse projection, you will see in this way. Clear or not? So these are the conformers. Conformers means in alkane, there is carbon to carbon single bond. And one carbon is fixed there. Molecules of other carbon, mean other carbon can rotate around the axis. Carbon to carbon single bond axis, it can rotate. During rotation, some special arrangement we will get, and those are known as the conformers. Okay, basically two are there, eclipsed and staggered. Some more between them lies between them, staggered and eclipsed. These are known as the skew symmetric. Okay, staggered is more stable and our eclipsed is less stable. In alkene, conformers are not there, beta. Alkenes do not form conformers. Why they are not forming conformers? Alkenes, alkynes, not. Because in alkenes, carbon to carbon double bond here. In alkene, only single bond. It can rotate easily. Okay, not free, but simply, practically it can rotate freely. We can say this one. But if double bond is here, then it cannot rotate. One bond can rotate, but second cannot rotate freely, na? Two bonds cannot rotate freely at one time. Clear or not? This rotation do not take place freely due to the double bond here, or in triple bond also. That's why in alkenes conformers does not take place. Then what type of isomer take place here? In alkenes, geometrical isomer take place. In alkenes, geometrical isomer take place. Geometrical isomerism means cis and trans. Cis and trans. Cis and trans. Cis means same molecules present in same space. Present in same space. Like if we have butene, then one carbon to carbon double bond, one carbon 2 3 4 at second double bond, CH3 CH CH CH3. We can show them in this way. This carbon and this one carbon, both are having double bond. This carbon, one bond with hydrogen and one bond with methyl. This one also one bond with hydrogen and one with this carbon. Here you can see methyl and methyl. Both are in same space. Both are in same space. And hydrogen in same space. So it is known as cis form. It is known as cis form. And if I write, yes Badal, if I write in this way, this is carbon to carbon double bond, here CH3, here hydrogen, here hydrogen, here CH3. Here carbon and hydrogens, CH3 and hydrogens in same space, but same molecules are in different. One is in upper, second in lower. Here one is in upper, one is in lower space. Means same molecules are lying in different space, and that is known as the trans. And here student, trans is more stable. Trans is more stable as compared to cis. As compared to cis. Because in trans, bulky groups are in opposite space. Okay, they are far apart already. And here same group are in same space. So these can repel each other. Repulsion taking place here. Due to more repulsion, here stability will decrease. Clear? Some other isomer like position isomer can also take place. Okay, but this is the main isomer of the alkene, that is the geometrical. They do not show conformers. Alkane show conformer only. Any doubt in conformers? Okay, so thank you. Have a nice day.